Let's learn how to solve by graphing and factoring quadratics. So we're going to talk about what does it mean to solve a quadratic equation, how many solutions can a quadratic equation have, given the graph, how do I solve it, and then we'll look at solving by graphing and solving by factoring. So let's get ready. You're going to need your notes and something to write with. And what does it mean to solve? So we've been solving in algebra for a while, and take a minute and solve this one. So I'm going to undo the 3 by subtracting it, and then undo the 5 by dividing by 5, and I get x equal 1. So to solve, that means I'm finding the value of x. Well, what would it mean here? So if I kind of try the same thing, if I subtract 20, then I get x squared minus 9x equals negative 20. Be careful, these x's cannot go together. One is an x squared and one is an x. So we kind of get stuck there. So we have to back up a little bit. Let's back up and just take a look at a graph instead. So solving means we're trying to find the value of x when y is 0. So when y is 0, what is x? Well, when y is 0, that means we're actually looking at the x-intercepts. We know that those are also called the roots. So I can see an x-intercept right there at 1, and I can see another one there at negative 3. Negative 3 and 1 are the answers to this quadratic equation. When you're asked to solve, that means what are the x-intercepts? So let's think about that and try to think about how many solutions we could have to a quadratic equation. So if we think our parabola that opens up and opens down, and how is it going to cross the x-axis? Well, if I have my graph, a lot of them are going to look like that. So I could have 2 answers. I could have one, maybe it opens down and it's tangent, it touches it at one spot. I could have one answer, and that would work for opening up as well. But I could have one that opens up and is above the x-axis, and we would say that that has 0 real answers. So if the solutions to the quadratic are the x-intercepts, how many x-intercepts could we have? We could have 2, we could have 1, or we could have 0. So just keep that in mind as we start to solve quadratic equations. You may get 0, 1, or 2 answers. So let's try to solve by graphing given the graph. So I want to look for the x-intercepts. I can see I have 1 at 5 and 1 at 1. So we would say x equals 1 and x equals 5. Let's solve this by graphing. This time we're given the equation, so we need to graph it. I notice it's in vertex form. So when we have inside the parentheses, I need to do the opposite. So this is going to go left 5 and down 4. So I'm going to graph that. And I have my vertex here at negative 5, negative 4. And then I'm going to use my step pattern. A is 1, so I'm going to go up 1 to the right 1, up 3 to the right 1. And then I can see I have an x-intercept at negative 3. I'm going to go back to my vertex, up 1, left 1, and then up 3, left 1. And that puts me at negative 7. So my answers here are x equals negative 3 and x equals negative 7. I can see that on my graph. Let's try to solve this by graphing. Notice this one is in standard form, so I need to find my vertex. I need to use this little formula. It is in standard form. A is negative 1, so I need to be careful with that, and B is negative 8. So I've got x equals negative 8 over 2 times negative 1. So that means x equals 4 over negative 2, which is negative 4. We have to find the y of my vertex. Be careful with these negatives. So y equals negative parentheses negative 4 squared minus 8 times negative 4 minus 12. Negative 4 squared is a positive 16, and then we want the opposite because of the negative out front. So this becomes negative 16 plus 32 minus 12. Left to right says 16 minus 12, and y is 4. So my vertex is negative 4, 4. My A is negative 1, which means my step pattern is negative 1, negative 3, and negative 5. So I'm going to graph that. Negative 4, positive 4. And then I'm going to move down 1 to the right 1, down 3 to the right 1. Go back to my vertex, down 1, left 1, down 3, left 1. Graph my upside down parabola, and I'm at negative 2 and negative 6. X equals negative 2 and x equals negative 6 for my answers by graphing. There's my graph, there's my answers. Now we're going to switch to solving by factoring. So this is another method. It will work when you can factor. You can't always factor. So when you solve by factoring, that means you're going to set your equation in standard form equal to 0, and then you're going to factor. And then we're going to use the zero product property. So the zero product property kind of looks like this. A times B equals 0. And it says if I'm multiplying two things and they're going to equal 0, then at least one of them must be 0. So A could be 0, B could be 0. So what we're going to see with factoring is we'll have two factors set equal to 0. So then I take the one and I set that equal to 0, and I take the other one and I set that equal to 0, and from there I can solve. Let's see what that looks like. So we're going to solve by factoring, not graphing anymore. This is in standard form. A is 1, B is negative 9, and C is 20. So I'm going to do my X puzzle. What multiplies to 20 and adds to negative 9? That would be 4 and 5, but they're going to both have to be negative. Because A is 1, I can go right to my parentheses. So I get x minus 4, x minus 5 equals 0. So this is in factored form, set equal to 0, so I can solve it using the zero product property. So I'm going to set each factor equal to 0 and solve. So I get x equals 4 and x equals 5. And maybe you've noticed that the factor, or sorry, the x-intercept, which is my answer, is the opposite of my factor. My x-intercept is the opposite of my factor. So my answers here are 4 and 5. I can check with the graph. I graph it, and I do see it goes through 4 and 5. Let's try this one. It's a little more challenging. I would like you to pause it and try to factor it by yourself. Here we have A is 6, B is 7, and C is negative 5. When I make my X puzzle, remember your A, because it has to be what multiplies to A times C. So A times C is negative 30, and what adds to 7. So two numbers that multiply to negative 30, well, 10 and 3, but I have to get them to add to a positive 7. So that means the 10 has to be positive and the 3 has to be negative. I cannot go straight to the parentheses because A is 6. So I want to take those two numbers and substitute them in for my B value. So I have 6x squared plus 10x minus 3x minus 5 equals 0. And then I want to factor by grouping because I have 4 terms. So I'm going to take out the 2x, which leaves behind 3x plus 5. The second part looks pretty close. I do have to take out a negative 1. That leaves behind a 3x plus 5, which is good because remember our parentheses have to be the same. Because the parentheses are the same, I can factor them out, 3x plus 5, and the other stuff left over goes in the other set of parentheses, 2x minus 1 equals 0. I'm going to apply the zero product property and set them equal to 0, so 3x plus 5 equals 0, 2x minus 1 equals 0. Take your time solving here because you've done all this work. Don't make a mistake in this part here. I'm going to subtract the 5 and divide by 3. So I get negative 5/3. And then I'm going to add the 1 and divide by 2. So I get 1/2. So we haven't solved the factoring to see these fractions, but when you do factor, you could get fractions for your answers. I graphed it, and you can see. So this is negative 5/3 here, and this is 1/2. That is not correct. So to recap, when we solve by graphing and factoring, when you solve by graphing, you want to graph it and then find the x-intercepts. When you solve with factoring, you're going to factor and then set each factor equal to 0 and solve. Keep in mind that quadratics can have 0, 1, or 2 solutions. Nice work.